Welcome to my YouTube channel. You are watching Tutor Online. In my previous lecture, I introduced you the basics of analytical chemistry. So let's continue that topic. As I told you before, there are two fundamental types of analysis. One is classical and second one is instrumental analysis. Classical methods are also called traditional methods. These methods are simple methods that are normally used in labs. They are cost effective as well. They do not need any equipment or instrument. That's why these methods don't give high accuracy. These classical methods are divided into two categories: gravimetric analysis and volumetric analysis. Let's have a look on gravimetric analysis first. It involves the quantitative measurement of analyte through the measurement of mass. In simple words, determination of any amount of material present by weighing the sample before and or after some transformation. For example, the determination of amount of water in a hydrate by heating a sample to remove water such that the difference in weight is due to the loss of water. Now have a look on volumetric analysis. Titration involves the gradual addition of measurable reactant to an exact volume of solution being analyzed until some equivalence or equilibrium point is reached. It is that point in a chemical reaction when the amount of reactants are chemically equivalent. It is also called stoichiometric point. Titration is a family of techniques used to determine the concentration of an analyte. When a chemist accurately titrates to the end point, he or she can measure the exact number of moles involved in a reaction. This helps to determine the concentration or the chemical composition of titrant solution. B is instrumental analysis, the type of analysis where modern equipments or instruments are used to get high accuracy. In this, the first method is called optical methods. The first instruments were developed for the use in visible region and therefore the methods are called optical methods. The other name of optical methods are called spectroscopic methods. Basically, in these methods, we study the interaction of analyte with electromagnetic radiations. There's difference between spectroscopy and spectrometry. In spectroscopy, we study the interaction of molecules with electromagnetic radiations, whereas in spectrometry, we measure the electromagnetic radiation interaction with molecules. Spectroscopy have many applications such as atomic absorption spectroscopy. It's a technique used to measure the concentration of metals and metalloids in a sample. Atomic emission spectroscopy it is a technique used to analyze the composition of a sample by measuring the light emitted from excited atoms. UV visible spectroscopy it is a technique that uses light to analyze chemical properties of a sample. In X-ray spectroscopy, we utilize the X-ray radiation to analyze the elemental composition of a metal by measuring the energy of X-rays emitted or absorbed when electrons in an atom are excited. Fluorescence spectroscopy analyzes fluorescence properties of a sample to determine its chemical composition. IR spectroscopy is a technique that measures how a substance interacts with IR light used to identify chemical bonds in a sample and to analyze the vibration of molecules, and so on. The second category is electrochemical analysis. This involves measuring some electric properties such as conductance, electrical potential, etc. of an analyte. These methods can be categorized according to which aspects of a cell are controlled and which are measured. There are four categories: potentiometry, colorimetry, amperometry, and voltammetry. In potentiometry, the difference in electrode potential is measured. In colorimetry, the transferred charge is measured over time. In amperometry, the cell's current is measured over time, while in voltammetry, relationship between current and voltage in an electrochemical cell is measured. That's it for today. If you have any questions, let me know in the comment section.